Welcome to the presentation on Ruby laser. I am Ms.K.Janani, Assistant Professor, Department of Physics, St.Joseph's College for Women, Tirupur. Laser. Light amplification by stimulated emission of radiation. Where do we see laser? The laser light is used by the children for playing games like shooting gun, and it might also be used for the pointing devices. Laser system in the range of 50 to 300 watts are used primarily for pumping, plastic welding and soldering applications. Laser above 300 watts are used in brazing, thin metal welding and sheet metal cutting applications. It may also be used in garment industry, communication system, heat treatment and barcode scanners. Let us see how does a laser light work. A laser is created when the electrons in an atom in special gases, crystals and glasses absorbs energy from an electrical current or another laser and becomes excited. The excited electron moves from lower energy orbit to higher energy orbit around the atomic nucleus. When it returns to the lower state, it emits laser light. Basic principles and steps involved in laser. To explain the process of light amplification in the laser, it requires an understanding of the energy transition phenomena in the atoms of its active medium. They include absorption, spontaneous emission, pumping and population inversion, and stimulated emission of the electromagnetic radiation. Let us discuss what is meant by absorption. An atom in the lower energy level absorbs a photon of frequency h nu and moves to an upper energy level. What is meant by spontaneous emission? The lower energy level is more stable than higher energy level. So, the electron tend to occupy the lower energy level. These electrons in the higher energy level decays into the lower energy level with the emission of electromagnetic radiations. This process is known as spontaneous emission. What is meant by stimulated emission? In laser action, the release of energy from an excited atom by artificial means is known as stimulated emission. It can also be stated as the stimulated emission takes place when the excited electron interacts with another photon of energy h nu. Key points. Ruby is a three-level laser system. It consists of three states E1, E2 and E3. E1 is the ground state, E2 is the metastable state and E3 is the excited state. Then it should attain population inversion. It involves the process of optical pumping and stimulated emission. Let us discuss what is meant by optical pumping. Optical pumping is a process in which the light is used to raise or pump the electrons from a lower energy level in an atom or molecule to a higher one. It is commonly used in the laser constructions to pump the active laser medium so as to achieve the population inversion. Some common optical pumping sources include laser diodes and discharge lamp, etc. What is meant by population inversion? The redistribution of the atomic energy level that takes place in the system so that the laser action can occur. Normally, a system of atoms in the temperature equilibrium, and there are always more atoms in the lower energy states than higher ones. Although absorption or emission of energy is a continuous process, the statistical redistribution of the atoms in the various energy states is constant. When this distribution is distributed by the pumping energy into the system, a population inversion will take place in which more atoms will exist in higher energy state than the lower energy states. This is known as population inversion. Ruby laser. It consists of a ruby cylindrical rod whose ends are optically flat and accurately parallel. One end is fully silvered and the other is only partially silvered. The rod is surrounded by a glass tube. The glass tube is surrounded by a helical xenon flash tube which acts as the pumping system. The ruby rod is a crystal of aluminium oxide doped with 0.05% of chromium oxide so that some of the aluminium atoms in the crystal lattice are replaced by Cr3+ ions. Achieving population inversion. At first, the chromium ions are excited from the level E1 to the level E3 by the absorption of light of wavelength 550 nanometer from xenon flash tube. The chromium ions in the excited state lose a part of their energy during interaction with the crystal lattice and decays to the metastable state E2. Thus, the transition from the excited to metastable state is non-radiation transition. As E2 is a metastable state, chromium ions will stay there for longer lifetime. Hence, the number of chromium ion goes on increasing in the state E2 due to optical pumping. The number of atoms in the ground state E1 goes on decreasing. As a result, population inversion is achieved between the states E2 and E1. E2 level is a metastable state with a lifetime of 3 into 10 power minus 8 seconds. Achieving laser action. Once the population inversion is reached, few of the chromium ions will come back from E2 to E1 by the process of spontaneous emission by emitting photons. The wavelength of the photon is 694.3 nanometer. This photon travels through the ruby rod, and if it is moving in a direction parallel to the axis of the crystal, then it is reflected to and fro by the silvered ends of the ruby rod until it stimulates the other excited ions and cause it to emit fresh photon in phase with stimulated photons. Thus, the reflections will result in stimulated emission, and it will result in the amplification of the stimulated emitting photons. This stimulated emission is the laser transition. The laser action is achieved between E1 and E2. This process is repeated again and again, and thus the photons multiply. When the photon beam becomes sufficiently intense, then a very powerful and narrow beam of red light of wavelength 694.3 nanometer emerges through a partially silvered end of the ruby rod. Conclusion. Once the chromium ion in the metastable state have returned to the ground state, the laser action stops. The output beam is monochromatic and coherent. The output wavelength of the ruby laser is 694.3 nanometer and the output power is 10 power 4 to 10 power 6 watts. The ruby laser operates only in pulsed mode. These are some of the self-assessment questions for ruby laser. The first demonstration of laser action using ruby crystal is given by T.H. Maiman in 1960. Ruby laser is a solid type laser. What is meant by optical pumping? It is a process in which the light is used to raise the electrons from lower energy level in an atom or molecule to higher one. It is commonly used in laser to pump the active laser medium so as to achieve the population inversion. This is one of the activity using laser light. Take a laser light and see what happens when it is passed through water. The laser beam is trapped inside the water because of total internal reflection. As the light tried to pass from the more dense water to less dense air, it bends. This is called refraction. These are some of the references for ruby laser. Modern Physics by R. Murugesan, Laser and Electro-Optics by Christopher C. Davis. Thank you.